everybody, it's Miss Phoebus, and I'm back again with Lesson 11, Relations and Functions. And one thing I want to tell you about this lesson and the lesson for tomorrow is that they're easy. So on a sheet of notebook paper, write down the words I know, the words I don't know. These are the four that I need you to look at right now. Relation, domain, range, mapping diagram. So a relation is a relationship, you can kind of hear it in its name, of sets of values. Usually the relation is a set of order pairs, and we're going to look at different ways to show those order pairs. Domain, all the input values, you're going to hear me use input, domain, and x values. All of those mean the same thing. So if I say domain, I may also say input or x value in that same place. Range are all the output values that are the y values. Sorry, lost train of thought. So range, output, and y values are all the same words, mean the same thing. So I could say, hey, what's the output, or hey, what's the range, or hey, what's the y values, and all of those should generate the same answer, same response from you. All right, now you are familiar with 3 out of the 4 ways that we are going to look at relations as well as functions. Function isn't on here, but we're actually going to talk about what a function is. It's a special type of relation. I didn't want to give it away at the beginning, but we'll talk about it. Mapping diagram shows how the elements are paired. So this is a mapping diagram. We're going to look at several examples of a mapping diagram, and it's basically just a way to show that you have a relation. All right, so your goal is to determine if a relation is a function by the end of the lesson. And this is our standard. Now we're only going to do part of the standard. We're just going to understand how a function is built from a set of domain and range values. And then we're going to look later on about how to graph them and how to state the domain and all of that kind of stuff. So here we go. We have one way we can write a relation is as a set of order pairs. So one thing, notice that all of my order pairs are in parentheses. That's like a pet peeve of mine, is that people start writing points and they don't wrap them in parentheses. Because if you have a whole list of these, like we have here, and there are no parentheses, then it's just a list of numbers. Those numbers would not have an x value or a y value. So definitely wrap those points in parentheses. Now, when I have a set of parentheses, I want to break out my curly braces. That indicates that we have a relation. It's one entire set. It tells you where to start on the left, tells you where to end on the right. And these order pairs, the x part is always first, and it's the input. The y part is always second, and it's the output. Another way that we can write relations is as a table. So I know you know order pairs. I know you know tables. Remember that your tables can be written vertically as well as horizontally. So all of my order pairs that I have up there are now written in table form. If you are writing something in a table, you have to kind of based off of how your orientation is. If you're going to write it vertically, you need to make sure the x is on the left and the y is on the right, just like x is on the left of the order pair, y is on the right of the order pair. With the horizontal table, you need to make sure x is on top and y is on bottom. Sometimes those aren't labeled. Sometimes they're labeled with something else, like what the value is, like number of miles driven and number of gallons of gas used. And so you don't know which one's x and y, but if you know, oh, x is always on the top or x is always on the left, you're good to go. If you know y is always on the bottom or y is always on the right, you're good to go. You don't need those written out that way. A relation can be written as a graph. So we can graph these. I have my table here, and so if I have a coordinate plane, I can graph 5, which means I go to the right 5, and -7 means I go down 7. 1, 2, 3, 4, 5, 6, 7. So I'm down here for this one. And it's hard because you can't like actually see me move my arm, but I'm going to try to talk my way through this. So Bear with me. We're always starting at the origin. I'm going to mark the origin right here. This is the origin. I'm always starting at the origin when I go to graph. And then the x part is positive 2, so I'm going to go to the right 2. My y part is 0, so I don't go up or down any. Right there is 2, 0. So I have that one done. All right, I'm going to start back at 0, 0. I'm going to go to the left 7, 1, 2, 3, 4, 5, 6, 7, and then I'm going to go positive 8 up, 1, 2, 3, 4, 5, 6, 7, 8. There it is, negative 7, 8. And then I'm going to go 6 to the right, 1, 2, 3, 4, 5, 6, down 6 because it's a negative 6, 1, 2, 3, 4, 5, 6. So there's that one. Negative 2 is 2 to the left. 8 is up. 1, 2, 3, 4, 5, 6, 7, 8. Right there. There's that one. And then I'm going to go right 6. 1, 2, 3, 4, 5, 6. And then I'm going to go down 7. Like right there. Okay. Now, you may need graph paper. I don't know how much longer we're going to be out away from each other, so that might be something you might want to put like on a list for somebody to go out and pick up. You can sketch these by hand. Let me show you that. So just on your notebook paper, you can sketch them. That one was a little curvy up there, but you want to kind of equally space everything out. So if you can't get graph paper, you can draw your own coordinate plane. It just makes it a little bit difficult, you know, you're like having to, you know, make sure things line up and things, you know, stuff like that. But we do that a lot in college, so you can do it. There's nothing wrong with practicing that. It's just graph paper is nice sometimes. All right, and then the last one, the mapping diagram. I love mapping diagrams. It's just a different way to be able to do these, to show these relations. But you're going to have some sort of shape on the left representing input, representing x's, your domain, and then some value as your output or your y value representing your range. But whatever is on the left, that has to be your input. So that's going to be the x part of your order pair. And whatever is on the right is going to be your output. So we're going to put this table in here, but I do want you to write some stuff down because you know how to write a table. You know how to draw a graph. You know how to write a set of order pairs, but these guys are new, so they kind of have some rules. So here are the rules. The left shape contains all the x values. The right shape contains all the y values. I already told you that. Oh my goodness, look here. It's in all caps, it's underlined, it's bolded, and it is italicized. And all of those things are done that way because it is important. There are no repeats. So if I go through my x's, and I see a repeat, like here 6 and here 6, I'm not going to write it 2 times. I'm only going to write it once. If I go through my y's, look here, -7 and -7, I'm only going to write it 1 time. And then you're going to draw an arrow from the input to the output. You're going to use arrowheads. It always points from left to right. It's always going to point to the right. Direction of that arrow matters. It matters, I promise. Okay? And so what we're going to do is fill these in and draw some arrows. So one thing that's teachers in the past that I have been with have really enforced or tried to enforce that numbers need to be written from least to greatest. If that is something that you want to do, great. It's not something you need to do. We're going to have a 5, a 2, a -7, a 6, a -2, but because this last 6 is already there, because of this one, I only have to write it 1 time. Uh-oh. Let's put that 6 back. Okay. And then, for the y's, -7, 0, 8, -6. I've got another 8, and then a -7. So I don't fill in any more. No repeats. Absolutely no repeats. Now, I'm going to change colors just so it pops, but you don't have to. And I'm going to draw an arrow from 5 to -7, and it points to the right. From 2 to 0 points to the right. From -7 to 8, points to the right. From 6 to -6, points to the right. From -2 to 8, points to the right. And from 6 to -7, points to the right. That's a mapping diagram. Shows the relation between those x and y values, and it connects them. And it's always because you have the input leading to the output. That's why the arrowhead is pointing, all of them are pointing towards the output. All right, so functions. I didn't want to give it away, but functions are important relations. So it's a relation in which each x has exactly one y. Each input has exactly one output. And one way, and probably the easiest way for a graph, is to be able to run the vertical line test. So a vertical line is a line straight up and down. And if it touches the graph more than once, then it's not a function. For everything else, we're looking to check to see, do the x's repeat? If the x's repeat, it's not a function. So I'm going to do some examples. I'm going to have 0, 3, 2, 3, 5, 3, 7, 3. Is this a function? Yes. What I'm looking for, do the x's repeat? I don't have any repeating x's. Now, notice that the y's repeat. That's okay. Y's are allowed to repeat all day long. That's why I use that as an example. Let me show you a non-example. 1, 2, 1, 5, 2, 2, 3, 5. That is not a function because this x and this x are the same x. They have different y's. That is not a function. So each x can have only one y. And so our problem is here. Not the fact that these two have a 2, not that fact. The fact that these, both of those order pairs, have a 1 as the x. Okay? Now you can do this as a graph. Do it over here as well. You can do it with the table too. Table, you're looking for the same thing. I'm going to show you something that looks like this. We're going to graph those later. I'm going to show you something that looks like this. You're not graphing those in this class. But anyway, a vertical line test says I drop a vertical line. Oh, it only crosses once. Crosses once, crosses once, crosses once, crosses once. Hey, it's a function. And I want to try, it's not like I'm going to avoid trying to cross a function or cross a graph where it would cross. I'm going to just drop it kind of in the middle and see what happens. Look at there. It's crossing 1, 2 times. 1, 2 times. There it happens again. 1, 2 times. Not a function. So these are not functions. Each x can have only one y. This x and this x have the same, or they're the same x, they have different y's. And that's not going to work. You can do the same thing with a mapping diagram. Okay, so here, function, each x has only one y. I have one arrow. You see a little arrow here? One arrow leaving each number. Here, this has 2 arrows leaving it. Here's one, here's one. So as soon as I have 2 leaving it, it's not a function. Now, you can write not a function as an f, and you can write a function as f. I'm okay with that shortcut. But you are looking for repeating x's, and you're also looking at using the vertical line test to help you determine, are we dealing with a function or not. So we're going to look at some examples. Oops, let's clear this out. Okay, so here's our vertical line test. Here is our function. Here is our function. And here is our function. Try to do those in green. The line that you see here, this is our vertical line test. We're testing to see if this is a function. And sometimes what I do is I actually take my pencil and I hold it kind of parallel to the paper, and I just kind of scan it across and sometimes that helps me. That pencil is my vertical line, okay? So I can also, and I kind of do it as a dash because I don't really want this to take over, but is it crossing one time or more than one time? So the one on the left is only crossing one time, so it's a function. Let's look at the one in the middle. One, it's crossing once, crossing once, crossing once, crossing once. Hey guys, that middle one's a function. Oh, look at this one. Even with this that's already there. See that? 1, 2, it's crossing twice. My green doesn't line up, but you know what's going on. Because that crosses twice, not a function. So that's your vertical line test part that you're watching out for. All right, so here I've got a mapping diagram as relation A. I've got a table as relation B, and then relation C is, and I'll go ahead and tell you, these are months of the year, and this is the number of days in that month. So if it's too fuzzy for you, you at least can think, okay, well, the months of the year, how many days are in those months? So I want you to pause the video. I don't have you try on here, but this is a you try. See if you can figure out if it's a function or not. All right, relation A. I have a mapping diagram. Each piece has one arrow leaving it. 1, 1, 1, 1. This is a function. All right, relation B, I'm looking to see, do my x's repeat? Oh, they do. You see right there? I have an x that's a 1 paired up with a 13, and I have an x that's a 1 paired up with a 19. So because of that, this is not a function. And then my relation C, you may have had a hard time seeing it, but right here, February is causing some problems. Because sometimes February has 28 days and sometimes February has 29 days. So because of that, this is not a function. All right, let's see what else we got. I think we have some more examples. So is it a function or not a function? Explain why. So this is like writing complete sentences. But you're going to see me write and say the same thing over and over again. And you are more than welcome to use that same sentence. So I look at my x's. 3, 4, 5. Oh, there's another 4. Because there's 2 4s, this is not a function. So it is not a function. And we're going to say because 4 repeats. Or you could say because each x does not have only one y. Because see, this y value and this y value, different. I like these. They're pretty straightforward. They always follow a rule. All right, so let's look. Now we're looking for number of arrows. So one arrow, one arrow, one arrow leaving C, one arrow leaving D. Each one has only one arrow leaving them. This is a function. Now y is receiving 2 arrows. That's not, we can repeat y's. So is it a function? Yes. Or is it a function or not a function? Let's not say yes. It is a function. Because each x has only one y. And that's the sentence you will hear me say over and over again. Is it a function or not a function? It's a function because each x has only one y. That's the definition of a function. Each x has only one y. All right, so we've got a graph. It kind of looks like a W. So I look here. I'm going to do my vertical line test. I'm not seeing any place where it's crossing, but I want to go all the way through. I want to see what I can find. I'm not seeing anything. It looks like it's only going to cross one time each time, so that means it's a function. Now here, you can say because each x has only one y, or you can say it's a function because it passes the vertical line test. And you can abbreviate VLT. I know what that means. Vertical line test. All right, so what do you think about this one? This is a set of ordered pairs. It's a relation. Every relation is a set of ordered pairs. Remember vertical line test. Ooh, right here, you see that? It's crossing 2 points. Not very well, I'm not crossing them, but 2 points right there. So because of that, not a function. You can say because each x does not have one y, or you can say because it fails the vertical line test. All right, so that's today's lesson. You are looking at relations, determining are they functions or not. You are explaining yourself, explaining why, so you're getting used to writing that sentence, and you are playing around with the vertical line test, playing around with looking at mapping diagrams. It's all kinds of fun. Thanks for coming and hanging out with me. I'll see you in the next video.